right, so Foster is traveling down Hendersonville Road at a comfortable speed of 45 miles per hour, 20.12 meters per second. So keep in mind that we're dealing with two unit systems. Make sure you're using meters per second. He sees a red light and slams on the brake. So apparently Foster doesn't drive and he doesn't stop for red lights, but we can still solve this problem. One thing that kind of clues us into the type of problem this is that we have a force and we have a time, we have a mass, and we have some change in velocity. So this is going to be an impulse problem, our first impulse problem on the quiz. And in this case, we know that impulse is equal to m delta v, and it's also equal to f delta t. Then from here, all we do is plug in numbers. So mass is 1800, velocity is 20.12, and then it changes to 0, so technically negative, but we'll ignore that. The force is what we're solving for, and the time is 2.8 seconds. Plugging all that in, you get that the force is equal to 12,934 newtons. Another way I saw people solving this, which is totally valid, but not exactly related to this unit, is to find the acceleration by simply doing velocity final equals velocity initial plus AT. And so if we know velocity final is equal to 0, velocity initial is equal to 20.12 plus acceleration and 2.8 for the time, then you can just plug in and solve for the acceleration. I haven't found that value yet, but it's a negative acceleration. I think it's negative 7 point something. And if you plug that in, force equals mass times acceleration. So 1800 times the acceleration, which is negative 7 point something. And that'll actually give you the same exact number, just in a different way. And it's your choice, really. I gave you points if you did it either way, even though technically impulse should be solved using, or this is intended to be an impulse question. Again, Newton's second law is really the same as impulse. Impulse is just another way of writing Newton's second law, because we have F is equal to m delta v over delta t, which, again, we mentioned this is an acceleration if we have delta v over delta t. So it's really just another way of writing Newton's second law. So either way really works.